Hi, and welcome to this video on MLOps Lens for Architects. In this session, I will be discussing end-to-end machine learning operations, that is MLOps for architects. My goal for this session is to help architects and developers to design an effective MLOps architecture for your organization. I will be introducing some of the effective components for an MLOps setup, explain why these components are necessary, and I will be discussing some of the challenges that exist today for typical machine learning life cycles that do not have an MLOps setup, and then further discuss how you can productionize your machine learning workloads with small changes in your approach. For this video, I will be specifically focusing on Amazon Web Services, and I'm going to start with some of the challenges or looking at a typical machine learning life cycle here. First, I want to quickly go over what a typical machine learning process looks like over here. So to make sure we are all on the same page, let's go through this iterative process step by step. Normally, you would start your machine learning process because you have a business problem which needs to be solved. And at this stage, you've probably determined that machine learning is the correct solution. Then you leverage a team of data scientists who will normally spend quite a lot of time collecting data required, iterating data from various sources, probably cleaning the data and analyzing the data. Next, the data scientist or machine learning experts will start to process all the data and create engineering features, training and tuning different machine learning models, probably evaluating the performance of these models against certain benchmarks. Based on the results, there would be quite a lot of to and fro going on here. The data scientists might go back to collect more data, probably refine some of the data to match their desired objective. Then the final step here, and certainly a crucial one, is to monitor the model that is in production, right? Much like a new car analogy, which when you buy a new car, which depreciates in value as soon as you drive it off a lot, a machine learning model is out of date as soon as you've trained it. It's really hard to keep up with the constant changing and evolution of uh, machine learning models and keeping your data up to date. For and these are really crucial factors for making accurate predictions. By monitoring the quality of your model, you will know when it's time to retrain it, perhaps even gather new data to get the right predictions. So let's let's look at potentially what is it that takes to meet your business objectives. So now that we've seen a typical machine learning iterative process, let's move on to see a architecture without MLOps in this case. So a typical machine learning iterative process through an architecture perspective. Here, I have a pretty standard data science setup. As you can see, I've narrowed down the approach a little bit with data scientist that has been given an AWS account. So we're talking really single account over here, just to keep it simple. Okay. Data might be pulled from a variety of different sources by the data scientists so that they can train their machine learning model, maybe in a SageMaker Studio notebook, and then create artifacts and store that in a simple storage or S3 bucket. So far, so good, right? Unfortunately, this is where it all stops. Gartner estimates that only 53% of machine learning POCs, that is proof of concepts, actually make it into production. And there are various reasons for this. Often, this is to do with a communication gap. Either there is misalignment between strategic objectives and machine learning models being built, or a lack of communication within different teams in an organization like DevOps, security, legal, data scientists, etc. Finally, if the company already has, say, a few models in production, for example, the data scientist has deployed a SageMaker endpoint and managed to get the machine learning set up to production, there are a number of loopholes that are involved in this setup that could potentially be disruptive. For example, any changes to the code or upgrades to your machine learning model rely on manual labor, that is, a data scientist having to manually make updates. Second, the code which the data scientist produced may be just stuck in Jupyter notebooks and SageMaker, which is very difficult to version and to automate. The data scientist might have even forgotten to turn on auto scaling for a SageMaker endpoint that they have deployed. So it cannot adjust capacity according to the number of requests that are coming in. Finally, there is no feedback loop involved. If the quality of the model deteriorates, you would only find out that through complaints and, say, disgruntled users. And that's really not a good experience for any organization. So, feedback loop is really important in addition to the other challenges that I mentioned here. So, these are some of the challenges which can be avoided with a proper machine learning and operations setup. What I'm trying to say here is that technology is meant to make our lives simpler through effectively involving people and processes to use the right technology. MLOps, which is similar to DevOps, it's just like a set of technologies or services. You need the right people, you need the right skill sets, following the same standardized process to successfully operate machine learning model at scale. The technology exists to make our lives easier. It's not to it's not the other way around. I will be focusing the rest of the video on specifically which AWS services you can use to build a successful setup so that you can avoid some of these challenges and hurdles to productionize your machine learning workloads. I want you to keep in mind that architectures provided in this video will only work if you have the right teams. So essentially right people, right skill sets, and are willing to establish and follow machine learning operations processes. I will include some of the links in this video, essentially well architected machine learning lenses, so that you can have a deeper discussions with your team and as well as gain in-depth knowledge on most of the components that I mentioned in this video. Moving on, I'm going to start with a smaller setup, the same setup as before, but more on a smaller scale so that we can make room for improvements in our architecture. I'm going to show you how you can introduce machine learning on operations to utilize technology for the better use and as well as for productivity. So to begin with, to improve collaboration, let's talk about the communication gap that we will try to accomplish with the help of technology. So here, to improve collaboration and resilience, we are going to add versioning for everything that is produced by the data scientist so that we know exactly how the machine learning workload has evolved. In case of troubles, we know that we have a known good state so that we can go back to the good version of the workload through a version setup. For example, here I have used AWS Code Commit. You could use any other code repository of your choice, for example, GitLab, or GitHub for code analysis. You can also use Elastic Container Registry for environments, so you can store your artifacts, or you can use S3, that is Simple Storage Service versioning feature enabled for storing your machine learning model artifacts. Next, let's shift the focus to the second challenge we identified, that is this inference endpoint, the SageMaker inference endpoint. We use the same setup as before, but this time we use, say, auto scaling groups for SageMaker endpoints to improve the availability and scaling. So, another improvement we can make here is to the inference model itself, is that every time we add a new feature, we could use a mechanism called as canary deployment. The canary deployment will make sure instead of replacing the old machine learning model with the new one, you can shift some of the traffic to the new model to test it before it's adopted fully by your users. If there are any issues, the endpoints can trigger CloudWatch alarms. Finally, I want to highlight how MLOps maturity model evolves. It starts with the experimentation phase, wherein you start to make a POC, a proof of concept. You identify repeatable processes, for example, code standards, what kind of machine learning solutions you want to use for your code changes or releasing features. You try to identify these patterns and make them repeatable. Then you introduce testing, monitoring, and multi-account deployment kind of use cases as your workloads get complicated and evolve to get to serve more users, of course. Last, start to identify how to scale your findings and productionize multiple machine learning solutions across your entire organization. The best practices mentioned in this video and as a general guidance from Amazon Web Services is made for you to experiment and see what fits your use cases, what looks for you. I hope that you found this video useful. If yes, please give it a thumbs up. Thanks.